My name is Olivia Rohrbach, and I am an environmental specialist here at the GTM NER. And I'll be talking to you all today about water quality monitoring in the Guana Estuary to assess ecosystem health. So why water quality? We've been talking about this a lot this morning, and water quality is really important to maintaining estuary health now and into the future. The Guana Water Quality Project came about 4 years ago based on local and residential community concern for the health of Guana Lake and Guana River. And this project took hold because of a lack of historical data about the Guana River and the Guana Lake itself. So we needed to create a baseline of water quality measurements to initiate management now and then to help protect this ecosystem going forward. This project is kind of like SWAMP. It's like a smaller kind of version of the SWAMP program, so set up very similarly. Just quickly again, here we are in North Florida, just south of Jacksonville, the GTM NER. I'm going to zoom in here on this yellow square for you into the Guana Estuary. The entire estuary is about 20 miles long. Starting here in the northern section, the headwaters, which are in the Ponte Vedra and Sawgrass residential communities, kind of all the inlets forming there. The star here in this photo is at Michler's Weir, which relates here to the star up top. And the Michler's Weir begins the 10-mile section of Guana Lake. That water flowing down and creating a lake here. In 1957, Florida Fish and Wildlife Conservation Commission, they impounded Guana River to create Guana Lake, and they manage it as a wildlife area for duck hunting and recreation activities like fishing and kayaking. So south here at the end of the lake, this little line corresponds up here to the Guana River, or the Guana Visitor Center and Guana Dam. And just south of the dam is the last 3 miles of the Guana Estuary, which is a intertidal brackish salt marsh and oyster habitat, also used for fishing and recreation as well. For the Guana project, we have 10 sites located within the estuary I just showed you all about, starting north here at Michler's and traveling all the way down to the bottom of that Guana River section. Every month we sample, so this star right here is our Pine Island reference site. So if you remember back to Shannon's presentation, Pine Island is the northernmost swamp site, and we use the data from there as kind of a reference to our smaller sampling site to just compare numbers and see how the water quality is going. So every month we take water quality from all 10 of those sites. We take grab samples, environmental data, and different things to determine the health of our water. What we have found jumping into the data. Just to get you oriented, I wanted to show this box plot. Excuse me, of the salinity gradient throughout the estuary. So if you look at the reading left to right, starting at Michler's Weir and traveling down to GR3, these box plots correspond north to south in the map here of the estuary, right? So traveling down to the end of Guana River here. And you can see the influence of tidal flow as water passes through the Guana Dam. So there is flow between the river and the dam. And you can see this salinity gradient as you travel north up to the very top of the estuary where it is a freshwater system. Dissolved oxygen, again, is a really good parameter to look at when talking about water health. And you can see throughout the 4 years of data that we have been collecting in the Guana Estuary, it's pretty stable, having a little bit of variability here at the northernmost sites. And some of those sites dropping below this red line, which represents a 2 milligrams per liter threshold, which also stands for a hypoxic water body. So hypoxia meaning there is little to no oxygen and not enough oxygen to support fish or plant growth or phytoplankton kind of life. So it's interesting to look at this monthly data and to see how some of these sites drop below this line, but most of the time the estuary is pretty well, doing well with dissolved oxygen. A curious addition to this data is that I also monitor a data sonde continuously at Michler's Weir. So this data sonde is in the water 24/7, 365 days a year, continuously taking water quality measurements every 15 minutes. And so if you look at the dissolved oxygen for this, that's coming off this sonde instead of my monthly sites, you can see here on this graph that the red is below that 2 milligrams per liter hypoxic threshold, and the gray is above. This is also just 1 year of data. And so this is showing that this continuous monitoring is giving us a bit of a different picture than we would get from the grab samples, which is interesting as this site is dropping below that hypoxic actually throughout the year. Getting back into the data I collect for the Guana Estuary, Dr. Dix mentioned that the Guana Estuary, both parts, the lake and river, are impaired for chlorophyll A. So this is my data from the past 4 years. You can see that there's not too much here in the northern sites, but it really spikes in the upper and middle lake sites. So in between these yellow and green sites, and then slowly, gradually is reducing as you get down to the southern portion of the river. It's interesting to note on my scale on the left-hand side there is almost up to 125, which is quite high for chlorophyll content. The state of Florida has thresholds for water quality and chlorophyll content. And to put into perspective why this estuary is impaired, the threshold for the river is at 6.6, which you can see here. I have a few sites closer to the dam that are above that threshold, and the threshold for the lake is 11 micrograms per liter. And you can see that my lake sites here are really reaching far over that threshold, which is why these sites are now impaired. Nitrogen, again, is something else we look at for water quality. And you can see we're seeing the same pattern in the concentrations of nutrients throughout the system. And they're lower up at those northern sites and really spiking there in the middle and upper lake sections, and then gradually kind of declining as you flow out into the river side. This is a breakdown of the nitrogen, just looking at the different forms of nitrogen. Shannon also talked about this as well. And there are two really interesting things about this graphic. It's looking at the lake, the river, and Pine Island, which is that swamp reference site. So the blue at the bottom is particulate nitrogen. The orange is going to be dissolved organic nitrogen. And then the black tips are dissolved inorganic nitrogen. And the two main takeaways from this chart are the fact that dissolved organic nitrogen is dominating as the nitrogen source, I guess, or kind of giving the most to that overall total nitrogen. And the other thing that you can see through this graph clearly is that the lake has a ton of nitrogen in it. I have the numbers reaching almost over 16 at times, milligrams per liter, with kind of the lake having a median of around 4 to 8. And then the river is really dropping down. You see those numbers are only barely reaching 4. And then that Pine Island reference site, those numbers are barely reaching 1. So just interesting to look at the variation in that nitrogen data. Phosphorus, again, is that third kind of key component to look at. If you note the scale bar there, we're just barely getting to 1 on the scale bar. So I have some phosphorus in the system, but not really a lot. And as you can see, it's fairly stable over time, the time we've been collecting the data. So we're going to get back into this nutrient stoichiometry that Shannon described for us in her presentation. Again, This Redfield ratio was created as a common ratio of nitrogen and phosphorus in marine ecosystems. And so just to refresh you, we have total nitrogen and total phosphorus, and you have that median in the middle of that 7.2 to 1 nitrogen to phosphorus ratio. Again, this means that if you are above the line with your data, it is most likely your system is high nitrogen and low phosphorus. If you are below this line, it most likely your system is high phosphorus and low nitrogen. So here we've plotted the Guana Estuary data onto this ratio graph. The blue dots are the lake sites and the orange dots are the river sites. And you can see as we've looked through my data that I have a lot of nitrogen in the system here. These blue dots, especially from the lake, really strong nitrogen here, which indicates that potentially this system is high nitrogen and low phosphorus based on this data. This is just taking the data from that chart and putting it into a numerical value. Again, that global ratio is 7.23, comparing to Pine Island at 9.66, which is slightly higher than the global ratio, comparing to the lake and river sites at 16.33 and 13.62. Again, just emphasizing the excess of nutrients we're seeing in the data just from the past 4 years, which is the length of this project so far. So what happens next at this point? The patterns we're seeing throughout the Guana Estuary could be sourced from many, many different factors. It could be coming from runoff from the headwaters up in Ponte Vedra. It could be pollution, septic, decaying vegetation is a big one that we're looking into, and it could be a lack of intertidal transfer. We're seeing kind of a trend in that where you saw those high values in the lake that then slowly sloped down as we got to the lower river sites. And so what are we doing about this? Well, as Dr. Dix mentioned, we are partnering with the University of Florida, and we are doing in this Guana Nutrients Budgets and Bivalves project. And so the idea of this project is to assess shellfish habitats in the Guana system and their ability to filter and remove nitrogen from the system. This project is a 3-year project, and we are in the first year right now. And so starting off, we have to take data measurements, look at where the oyster habitats are, the different shellfish habitats, determine how much nitrogen is in the system and how much is being filtered and how much is leaving the system. To do this, we have here pictured on the right nitrate sensors that are set up at Michler's, which is that northernmost site I was talking about. And the picture in the middle is a nitrate sensor in Guana Dam. So we are looking at the nutrients flowing into the system and then flowing out at the dam site to try and kind of create a picture to better understand what's happening. Further on, after this first year of data collection, we would then use this to propose management implications and to kind of determine how to continually help this system, if not remediate it, and protect it into the future. Thank you.
Thank you so much, Olivia. It's great to hear about the efforts that you are part of in the Guana Lake and Guana River Estuary system. We do have a couple of questions in the chat box for you. The first is, has GTM monitored any indicator plant species in the water bodies, such as cattails, for increased occurrence to see if they could be used as an early or late indicator for higher nutrient level in addition to sampling the water?
Great question. I don't believe we have done any vegetation surveys. However, that is something I'm personally interested in because of the density of submerged vegetation we have at the northern part of the lake. There are a few invasives at the northern part of the lake that FWC, who manages the lake, is taking care of with some management implications that they have, but I don't think the GTM is looking at that necessarily right now, but definitely will be something we'll consider in the future.
Great, thank you, Olivia. And Nikki has responded in the chat box to this question, but could you talk about the flushing time for the lake and for the river, and how the Guana Dam might impact what you're seeing in both of those water bodies?
Mm-hmm. Yep. Just looking at Nikki's comment as well. We don't have that information necessarily yet. We're hoping maybe part of this project could be the collaboration project with UF could get us some more information on that, because that is one of our something we're thinking about is flushing time has a impact on that. You could kind of see that trend throughout the nutrients in my data. So great question. Again, still a work in progress here.
Thank you, Olivia. All right, are there any additional questions either in the chat box or through raised hands from our audience today? All right, we've got a great question that just came in. There continues to be work being done at the Michler Weir, removing plants and digging up sediment. Have you seen any of those activities impact the data that you've been collecting?
This is something that I also am looking at, and we are looking at with the monthly grab samples. There's potential that some of the plant removal and dredging that happens above the weir, or even excessive water flow through the weir, is affecting that data. But what's interesting is that DataSon that I also manage, that we manage, has continuous data. So I believe that kind of correlating that data with times of plant removal or rain events or other events that are affecting that weir in particular would give us a really good picture of how much interaction is happening there, if there is, and how much is changing.
Great, thank you so much, Olivia.